All right, so ready to dive into the world of LLMs and transformers? I mean, this stuff is everywhere right now.
It really is. And it seems like everyone wants to understand how it all works.
Well, that's where this deep dive comes in. Our listeners sent us an entire guide all about LLMs and transformers filled with code tutorials, exercises, the whole 9 yards.
Sounds like they're ready to get their hands dirty.
Oh.
It's not just about understanding the concepts, but actually seeing how these models work in practice.
Exactly. But before we jump into the code, let's start with the basics. What exactly are we talking about when we say LLMs or large language models?
We'll think of them as AI systems that are basically learning to understand and generate human language. They're the brains behind those chatbots that can hold conversations, or the tools that can summarize long documents in a flash, or even those AI writing assistants.
Oh, yeah, those things that can help you write the perfect email. So they're like super-powered language whizzes. But what makes them so good at what they do? I keep hearing this phrase, transformer architecture.
Ugh. Ah, yes, the secret sauce. Before Transformers, we had models like RNNs and LSTMs, which were good, but they had trouble with long sentences. It's
Yeah.
like trying to remember what you had for breakfast a few days ago while you're planning tonight's dinner. Sometimes those details get lost, right?
Yeah, things get a little fuzzy.
Exactly. Older models had that same problem. They struggled to connect information that was spread far apart.
So they had short attention spans.
You could say that, but then in 2017, a paper called Attention is All You Need came along and introduced this revolutionary transformer idea. Instead of processing language bit by bit, transformers can look at an entire sentence or even a paragraph all at once using something called self-attention.
Self-attention. So are these models like meditating on the meaning of language or something?
Well, maybe not quite meditation, but it is about focusing on the important parts. Think about how you read a news article. You don't give equal weight to every word, right?
Definitely not.
Your brain picks out the key phrases, the important ideas. And that's what self-attention allows the model to do, to prioritize the most important words in a sentence, just like our brains do.
So it's not just reading the words, it's actually understanding the important parts. That's amazing.
Right.
I can see how that would be a total game changer for things like translation.
Oh, absolutely. Imagine you're translating a sentence from English to Spanish. Self-attention helps the model understand how words in both languages relate to each other by considering the whole context. It's not just looking at individual words in isolation. This leads to more accurate and more natural-sounding translations.
Okay, I'm starting to get why everyone's so excited about this. So we've got this transformer architecture, which sounds like a pretty powerful engine. What are some of the key components under the hood?
Well, first we've got the encoder-decoder structure. Think of it like a conversation. The encoder is like you listening and understanding what someone is saying, and the decoder is you formulating your response.
Oh, okay, I see.
The encoder processes the input, like the sentence you want to translate, and then the decoder uses that information to generate the output, which would be the translated sentence in our example.
So it's like a two-way communication system. That makes sense. What about this positional encoding thing? Does that have something to do with how these models understand word order?
You got it. Unlike older models that process language step by step, transformers can look at an entire sentence at once, but they still need to know the order of the words right. Positional encoding is like giving each word a specific address in the sentence so the model knows where everything fits.
So each word gets its own little GPS coordinate. I love that analogy. But let's go back to self-attention for a minute. We know it's important, but how does it actually figure out which words deserve the most attention?
This is where it gets really interesting. Self-attention uses these things called queries, keys, and values. It's kind of like a search engine. You've got a query, which is the word you're trying to understand, and then you've got keys associated with all the other words in the sentence. The self-attention mechanism compares the query to each key to see how relevant they are to each other.
So it's like a giant matchmaking game for words. Every word's trying to find its perfect partner.
Exactly. And the value associated with each word provides the model with the information to create its final representation. So words with higher scores, meaning they're more relevant to the query, will have a bigger impact on the overall meaning.
So it's all about those power couples in a sentence. That's so cool. I'm really starting to see how all these pieces fit together to make these models so good at understanding language. But what does all of this actually mean in the real world? How are these powerful LLMs being used today?
Now that's where the real fun begins. Get ready to be amazed because the applications of LLMs are truly vast. They're already revolutionizing how we create content, how we interact with technology, and so much more.
Okay, I'm all ears. Hit me with some real-world examples.
Well, let's start with something you're probably seeing in your everyday life already, content creation. LLMs are changing the way we write, everything from articles and blog posts to even code.
Yeah, it seems like AI writing tools are popping up everywhere these days.
And it's not just about writing articles. Imagine having an AI assistant that can help you design a website layout or write a function based on your instructions. I mean, the possibilities are really expanding.
That's pretty wild. But I have to admit, part of me wonders what happens to human writers and coders if AI can do all of that.
It's a valid question for sure, and one that a lot of people are thinking about. But for now, let's focus on the positive potential. Think about customer support, for example. How many times have you been stuck chatting with a chatbot that just couldn't understand your question?
Oh, way too many times. It's so frustrating.
I know, right? Yeah. But LLMs are changing that. They can power chatbots that are actually intelligent and capable of understanding more complex questions and providing really helpful answers. This means faster, more efficient, and a lot less frustrating customer service experiences.
Sign me up for that. What about something like translation? I've always been fascinated by how language can connect people from all over the world.
Yeah, translation is another area where LLMs are making a huge impact. They can translate languages faster and more accurately than ever before, breaking down those communication barriers and really opening up a whole world of possibilities for travel business, global collaboration, all sorts of things.
It's like having a universal translator right in your pocket. Okay, I'm definitely seeing the potential here. This is really exciting stuff.
It is, and we've only just begun to scratch the surface. There are so many different types of LLMs out there, each with its own unique strengths and capabilities.
Okay, now I'm really curious. I've heard of GPT-3, but what are some of the other big names in the LLM world?
Ah, yes, GPT-3. It's definitely a rock star. It's developed by OpenAI, and it's known for its ability to generate incredibly realistic and creative text. I'm talking everything from stories and poems to code, and even scripts.
Wait, Screps? So is that how you wrote this episode? Just kidding. But seriously, it's amazing what these models can do. What else is out there?
Another major player is BERT, which was developed by Google. It stands for Bidirectional Encoder Representations from Transformers. Unlike GPT, which processes text in one direction, BERT looks at words in both directions, considering the context that comes before and after.
So Bert is like that friend who always remembers the full story, not just the last chapter.
Exactly. BERT excels at tasks like question answering and really understanding the nuances of language. And then there's T5, that stands for Text-to-Text Transformer, also from Google. It's known for its versatility. It can handle a wide range of language tasks with a single unified approach.
So we've got the creative GPT family, the context-aware BERT, and the adaptable T5. It sounds like an all-star team of language models, each with its own special skills. But how do these models actually learn to do all of these amazing things? How do they get so smart?
That's a great question. Training these large language models is a fascinating process. It involves two key stages: pre-training and fine-tuning.
Okay, so pre-training is like boot camp for language models?
Exactly. It's the initial training phase where the model is fed massive amounts of text data. I'm talking books, articles, websites, anything and everything they can get their hands on. And this is where it learns the fundamental rules of language grammar syntax, how words relate to each other, all that good stuff.
So it's like learning a new language by immersing yourself in the culture and absorbing everything you can.
Precisely. And what's great about pre-training is that it creates this foundation that can then be used for a variety of different tasks. Then comes fine-tuning, which is where we get more specific.
So it's like going from general practitioner to brain surgeon.
Perfect analogy. Let's say you want to build a chatbot specifically for customer service. You would take a pre-trained model like BERT and then fine-tune it on a data set of customer interactions. This teaches the model the specific language, the tone, the knowledge needed for that particular job.
So pre-training lays the groundwork, and then fine-tuning hones those skills for a specific purpose. Makes sense. But how do we know if a model is actually good at what it does? Is there some kind of test they have to pass?
We do have ways to measure how well these models perform. There are metrics like perplexity, which basically tells us how well a model predicts the next word in a sequence. Lower perplexity generally means the model is doing a better job.
So it's like measuring how surprised the model is by the next word. If it's constantly surprised, it's probably not understanding the language very well.
Exactly. We also have BLEU scores, which are commonly used for evaluating machine translation. It compares the model's translation to a reference translation and tells us how closely they match.
So it's like a plagiarism checker for language models. So we've covered the basics of transformers, the different types of LLMs, how they're trained, and even how we measure their performance. But I'm curious about the practical side of things. How do people actually build and use these LLMs in real-world projects?
That's where things get really interesting. Building and deploying an LLM might seem daunting, but there are actually some incredible resources available that make it surprisingly accessible.
Okay, so now you've got my attention. Tell me more about these resources. Okay, so you're saying that building and using these powerful LLMs is actually within reach for like regular people.
It really is. There are libraries like the Hugging Face Transformers library
Okay.
that provide pre-trained models and all the tools you need for fine-tuning and even deploying your own LLM. It's
Wow.
like having a whole workshop full of ready-made parts and instructions.
So you don't need to be like a coding genius to get started.
Not at all. Of
Yeah.
course, some coding knowledge is always helpful, but these libraries really make it easier for anyone to experiment with and build some amazing applications using LLMs.
That's incredible. It feels like we're at this real turning point in how we interact with technology. But with all this talk about building and using LLMs, what's next? What does the future hold for these incredible tools?
The future of LLMs and transformers is, well, it's incredibly exciting. Researchers are constantly pushing the boundaries, exploring all sorts of fascinating avenues. One area that's really interesting is this idea of zero-shot learning.
Zero-shot learning. That sounds almost too good to be true, like teaching someone a new skill without any training at all.
It's a bit like that. The goal is to enable models to perform tasks they've never been specifically trained for. Imagine a language model that can translate between languages it's never even encountered before, or write different kinds of creative content without needing specific examples.
That would be revolutionary. It's like having a universal translator that can unlock any language in the world.
It really is.
Yeah.
And another area that's super fascinating is common sense reasoning. Current LLMs are really great at mimicking human language,
Yeah.
but they often lack the basic common sense that we humans take for granted.
Right, like knowing that water is wet or that you can't fit an elephant in a refrigerator, things that seem obvious to us
Exactly.
might stump even the most advanced AI.
Exactly. Researchers are working on giving LLMs this kind of common sense,
Oh, wow.
allowing them to better understand the world and make more nuanced judgments.
So it's about moving beyond just mimicking language to actually understanding the meaning and the context behind it. That's incredible. It feels like we're on the verge of some really groundbreaking advances.
We are. It's an exciting time to be following the development of LLMs and transformers. These models are opening up new possibilities in so many areas, from how we create content to how we interact with technology and even how we understand the world around us.
This whole deep dive has been a real eye-opener for me. I'm feeling really inspired by the potential of these tools and excited to see what the future holds. Thanks for taking me on this journey.
It's been my pleasure. And to our listeners out there, remember, the journey of learning never ends. Keep exploring, keep asking questions, and keep pushing the boundaries of what's possible.
And on that note, we'll sign off. Thanks for joining us on the deep dive. Until next time, stay curious.